Coterminal angles have the same terminal ray, assuming the angles are in standard position. Remember that standard position simply means that the initial ray is on the positive x-axis. So let's draw a random angle alpha. We'll assume that this is the angle alpha, rotating counterclockwise from the initial ray to the terminal ray. One fairly obvious coterminal angle would be the angle found by rotating clockwise instead of counterclockwise. So angle alpha and angle beta are coterminal. Another possibility is to rotate multiple times. So we can rotate around perhaps like that. We'll call that angle gamma. All three of these angles are coterminal, alpha, beta, and gamma. They're all angles in standard position, and they all have the same terminal ray. So that makes them coterminal. Let's do a mathematical example. Let's suppose that we have an angle alpha. Let's suppose it's equal to 130 degrees. If we wanted to find coterminal angles to 130 degrees, we would add or subtract multiples of 360. So if we add 360 degrees, that will give us a coterminal angle. And we can continue on adding 360 to get different coterminal angles. So these three angles, 130, 490, and 850 degrees, are all coterminal. Similarly, we can subtract 360 from 130 to get negative coterminal angles. So we have 130 degrees. If we subtract off 360, we would end up with negative 230 degrees. That's not a 3. Let's try that again. Negative 230 degrees. That angle is coterminal to 130, and we can continue on in this way, finding more negative coterminal angles. So 130 degrees, negative 230 degrees, and negative 590 degrees. Those are also coterminal angles. This is the process if we're dealing with angles that are in degrees. Now, if we wanted to deal with angles that are in radians, instead of adding or subtracting 360 degrees, we would add or subtract 2 pi. The process is the same though. Hope this helps.